Okay, so now we're going to talk about some applications of rational equations, and that's just another word for word problems. I'm going to break these down into some categories for you. First, let's do some work examples. Generally, with the work example, you have usually two people working on the job, and you're given some information, and you might be asked how long would it take them to do the job if they work together, or you might be asked how long would it take each person to do the job. So let's take a look at this problem. A mason can construct a retaining wall in 18 hours. His apprentice can do the job in 27 hours. How long would it take them to construct the wall working together? Okay. Let's let X be the time it takes them to complete the job working together. Notice I said one job. That'll come into play in a minute. Now I like to set up a table on these. So we have two people working. We have the mason and we have the apprentice. Now the first thing I want to realize here is how much time will each spend on the job. Now I'm going to assume, and that's what we should do here, we should assume that each one of these will work on the job until the job is done. So they're both going to work the same amount of time, and since X is the time it takes them to complete the job, they're both going to work X units. In this case that would be hours. So they're both going to work X hours. Now if you know a guy can do a job in 18 hours, then that tells you that he can do 1/18 of the job per hour. So he works at a rate of 1/18 of the job per hour. So now, let's think of it like this. If you multiply the number of hours the mason works on the job, which is X, times the rate the mason works, which means he does 1/18 of the job per hour, then the portion of the job completed by the mason would be X times 1/18, which is the same as X over 18. Now we know the apprentice can do the job alone in 27 hours. So that means the rate the apprentice works, he works at a rate of 1/27th of the job per hour. So if we want the portion completed by the apprentice, we take the number of hours the apprentice will work, which is X, multiply it by his rate, which is 1/27th, and we get X times 1/27th, or X over 27. Now, if you add the portion completed by the mason and the portion completed by the apprentice, they should add up to 100% of the job. So 100% of the job in decimal is 1. So put a 1 here and then just add the two portions that they do, and that should equal 1, because this is the portion done by the mason. The portion done by the apprentice should equal one whole job, or 100% of the job. Now to solve this, 18 and 27 will both divide into 54, so the LCD is 54. So we learned earlier that to solve rational equations, you just multiply each term by the LCD. So X over 18 times 54, well, we know 18 goes into 54 3 times, so that would be X over 3, X times 3, so it's 3X. And then X over 27 times 54, well, 27 goes into 54 2 times, so X times 2 would be 2X. And then multiply 1 times 54, we get 54. Now, add these together, you get 5X equals 54. And so X would equal 54 divided by 5, which is 8 4/5 of an hour, or I'm sorry, 10, not 8. It's 10 4/5 of an hour, and 10 4/5 of an hour in decimal would be 10.8 hours. So if you want to know the minutes, you'd have to multiply 0.8 by 60, and that would tell you the minutes. I think that's 48 minutes. So if you wanted it in hours and minutes, it'd be 10 hours and 48 minutes. One last thing I want to say about this is it would make sense that if these two guys work together, then the time it would take them working together should be less than the time of the one who can work the fastest. So certainly it should be less than 18 hours, because if the mason's getting help, then the apprentice should actually be speeding the time up a bit. So that's what's happening there. Notice 10.8 is certainly less than 18 hours. Okay, here's another work problem. A new printer can print payroll checks 3 times faster than the old printer. Working together, the two printers can print the payroll in 7.5 hours. How long would it take each printer to do the job working alone? Okay, so let's let X be the time for the faster printer to do the job working alone. Okay, then that means that the slower printer is going to take more time. So the slower printer is going to take 3x. So in other words, if it takes the faster printer 2 hours, it'll take the slower printer 6 hours. Okay, now we know when they work together, they can complete the job in 7.5 hours. So in this problem, we know the time working together is 7.5 hours for both the faster printer and the slower printer. Now, the rate, if it takes the faster printer X hours to do the job, then its rate must be 1 over X. In other words, it must do 1 over X portion of the job per hour. And if it takes the slower printer 3x hours to do the job, then its rate must be 1 over 3x. So it does 1 over 3x portion of the job. And then to find the portion completed, multiply 7.5 times 1 over x and 7.5 times 1 over 3x, and that'll give you the portions. Now, by the way, 7.5 times 1 over 3x, you can actually divide 3 into 7.5 and get that just 2.5 over x. So this one, the first one is 7.5 over x, and this is just going to be 2.5 over x. And again, so this is the portion of the job done by the first printer, or the faster printer, and this is the portion of the job done by the slower printer, and you add those two portions together, and that should equal one job. And then since these have like denominators, we can just add the numerators and get 10 over x. And then if you multiply both sides by x to get rid of the denominator, if you multiply the left by x, you'll get 10. If you multiply the right by x, you'll get x. So you get x equals 10 hours. So the faster printer can do the job in 10 hours, and the slower printer can do the job in 3 times that, in 30 hours. Now that's if they're working alone. Okay? The next example is uniform motion problems. So we have a commercial jet that goes 620 miles an hour, or 620 miles in the same amount of time that a corporate jet travels 1,260 miles. The rate of the commercial jet is 120 miles per hour faster than the rate of the corporate jet. Find the rate of each jet. Okay, since we want to find the rate of each jet, we need to let R be the rate of one of the jets. So let's let R be the rate of the corporate jet. And then the commercial jet is faster, so R plus 120 would be the rate of the commercial jet. Okay, now we know the corporate jet travels 1,260 miles, and we know the commercial jet travels 1,620 miles. We've got their rate. Their rate is R for the corporate jet and R plus 120 for the commercial jet. Now, you might remember the formula distance equal rate times time. Well, then that can be written as time equal distance divided by rate. So if I take the distance the corporate jet travels divided by rate, I get 1,260 over R for the time it takes the corporate jet to travel. And if I take the commercial jet's distance divided by its rate, that should give me the time it takes for the commercial jet to travel. Now, what we know is we know their times are the same. So since we know their times are the same, we can set the time for the corporate jet equal to the time for the commercial jet. And now we have a proportion, and you can solve by cross multiplying. And I'll let you, you can freeze the video if you want to, but you can see I just cross multiplied and then I solved for R here. So I ended up getting R equal 420 for the commercial jet, and since the corporate jet, is 420, and then the commercial jet is 120 miles per hour faster, so that would be 540 miles per hour. Okay, so there you have it. There's the first uniform motion problem. Okay, here's a problem. A train and car leave the same town at 3 p.m. and head for a town 280 miles away. The rate of the train is twice the rate of the car. If the train arrives 4 hours ahead of the car, find the rate of the train. Okay, so we're going to let R be the rate of the car, and so 2R is the rate of the train, because the train's twice as fast as the car. So we know both vehicles went 280 miles, we know their rates, and we know time is distance over rate, so we know 280 over R is the time for the car, and we know 280 over 2R, which is 140 over R, is the time for the train. And since the car must equal 4 more hours than the time for the train, we put the time for the car here, and we set it equal to the time for the train plus 4 hours. Now we've got, these are like denominators, so I can actually move this across and subtract it from this. So I have 280 over R minus 140 over R equals 140 over R. And so I can write 140 over R equals 4 over 1, and then I can cross multiply and get 4R equals 140, and then divide by 4 and get 35. So the rate of the car is 35 miles per hour, and since the rate of the train is twice that, the rate of the train is 70 miles per hour. Go ahead and pause the video and read this, and I'll just go ahead and get to the solution. So we're going to let R be the rate of the current, and then so the rate of the boat when it's traveling with the current would be 18 plus R, and the rate of the boat traveling against the current would be 18 minus R. So we've got the boat taking 2 trips, one with the current, it travels 44 miles, and then against the current it travels 28 miles. I just told you the rate with the current and the rate against the current, and so the time is equal to distance over rate. So with the current would be 44 divided by 18 plus R, and against the current 28 divided by 18 minus R. Now those times are the same. The problem says those times are the same, so I just set these two times equal to one another, and then I can cross multiply. So just cross multiply here and then solve for R, and you'll get R equals 4 miles per hour. So the rate of the current is 4 miles per hour. So again, if I went a little too fast on that one, just stop the video and then go back over it. This is a number problem. It's pretty straightforward. It says a number plus twice its reciprocal is 11/3. Find the number. So I'm going to let n equal the number. So I have n plus twice the reciprocal, which is 1 over n, equals 11/3. And now the lowest common denominator for these fractions are 3n. So just multiply each term by 3n, and then you get 3n squared plus 6 equals 11n, and then move the 11n over, you get 3n squared minus 11n plus 6. Then you factor that, set your factors equal to 0, and solve them, and you get 2 answers. N equals 2/3 and n equals 3. These are some pretty simple proportion problems, so I'm just going to let you pause the video and read these and see how I work them. I'm about to run out of time, so I'm going to go ahead and just show you. For this one, I know 5,000 is to 425 as x is to 765, so I just cross multiply and then solve for x to get x. And then on the next one, I know that 2 gallons is to 30 as x is to 75 gallons, and so I can cross multiply here and then solve for x and get 50 gallons for the answer. And then on this third one, with similar polygons, we have 2 right triangles here, and so I can say, well, I can say 15 is to 20, 15 is to 9, I'm doing it this way, 15 is to 9 as 20 is to x. Okay, so 15 is to 9 as 20 is to x, and then you can cross multiply and get x is 12. And then on the last one you do the same thing, but you can do 15 is to 12 as 20 is to y, and then you can cross multiply there and get the y values. Okay, so anyway, again, freeze the video if you need to, and then look these problems over and solve them. I've got one more section to cover.